Okay, to recap here, we have now got we've got our code to the point where we can run an image or load an image and display it. I'm displaying two separate images here, and they're on the screen. So our next step is to move the images around. And there is one thing here I noticed that for both Studio Sketchpad itself and in the regular processing, you see that the Sketchpad one is running in JavaScript in the browser's JavaScript engine, and this is running on the Java virtual machine, which are two completely separate architectures. And I had thought that maybe the reason these black shadows were appearing was because of the because it was some kind of JavaScript or browser issue, but really this is happening in processing itself too. So either I've just been really silly and my images didn't get exported with transparency, which I mean, if I look at them in my Explorer, I see that there's that fuzzy little drop shadow there, and instead that semi-transparent drop shadow is being turned into these black lines. So there's either it's surprising that processing doesn't support both of those. So we have a mystery on our hands, and I've added that to the bottom of the list here. But right now we just want to look at moving the image with some kind of input device. And since I am on a computer here instead of a phone or something, I'm going to use a well, we have the choice of basically the keyboard or the mouse, and so I'm going to go with the keyboard, and I'm going to try and have these guys move around. And let's say we'll move this blue guy with the keyboard, and then I will leave it as an exercise for you to move the orange guy with the WASD keys. Actually, I'll do it the other way around, because I'll do the WASD keys because I have a Dvorak keyboard, and I tend to use special code. So I'll show you how to do multiple types of input and map them both to the same action here. And if you saw my images again, you'll notice that I'm set aside two ways to where'd it go? I set aside two different ways to change the direction that we're looking. And I'm going to show you just a little bit about, well, I guess I can do one character and you can do the other character. And that'll help us out. And I'm going to choose to just use 4 separate images rather than trying to use the sprite sheet, because it's not hard. And in fact, I looked at I looked it up, and all I did was I typed. I did the same thing I did to find out about this load image thing. I went to Google and I typed processing, which is our language, and sprite sheet, which is what these little things are called in the industry. And I found a bunch of links, and I just arbitrarily clicked on this one. I guess maybe because it said the word simple in it, and it links to this guy's or lady's, somebody's person, probably that guy. Interesting guy. Okay, there we go. And it's his example code, which is really short. And you can see that what he's done is he's done exactly what we did. He had a P image, and he called it a sprite sheet, which is just the name he gave to that image. And again, he's sprite sheet, load image, just like our code. And then, but for the player, which is also a P image, instead of calling load image, he calls create image. And I'm 32, 49, those would be the dimensions. And ARGB means alpha, red, green, blue, which you probably know that if you're a graphics guy. And that A is intriguing because that might be a clue to our transparency issue, the fact that that's there. But in any case, so he is creating an image, the player, which is 32 by 49 pixels, and then he is copying from the sprite sheet to yeah, okay, so I don't know what this means. I don't know what these numbers mean, but my guess is that he's copy from the sprite sheet from these pixels, the width and height, which as you see matches the width and height there, to the coordinates 0, 0, which is the upper left-hand corner of the player. So copying this rectangle right here from the sprite sheet to the player, and then he only displays the player at those coordinates. So he could, if he wanted to. So basically, you know, he's extracting one. He doesn't actually have a. I don't know if that's his. I don't think that's his sprite sheet, but I don't actually see the image of the sprite. But you can imagine this is our. You know, so instead of sprite sheet guy.png, you could just say, oops, you know, orange guy or blue guy. I guess guy is an industry standard term. And so you imagine he's pulling a rectangle out of here and assigning it to a image that he created in memory that's at the exact same size as one of the cells. And that's pretty easy to do. So I invite you to try that because it would make the code a lot cleaner, perhaps, to I don't know if it would necessarily in this case because there's only 4, but my guess is it would look a lot nicer in the code if you use the sprite sheet image. So I'm leaving that in SketchUp, but Sketchpad, and I'm leaving that for you to use and to try. But I'm going to use these because I guess I'm lazy. But you know, usually or at least often the framework will take care of the sprite sheet stuff for you, and it doesn't look like processing has this built in, so you can just copy that guy's code and then you'll have it. And then of course you'll want to change the location of the rectangle, which is just adding and multiplying, or you know, by the width of this of the base image. They're all the same size. I believe it's a 200 by 50 image. Yeah, 200 by 50. So yeah, so let's. So I'm going to use these, and I invite you to use the sprite sheet method and try that for yourself. But for the sake of being very simple, we will do the explicit stuff. Well, a lot of the advanced, you know, a lot of better programming or advanced programming is about saving yourself work. So, you know, here we're going to basically duplicate a lot of code to, you know, we're going to, for example, copy, you know, we're going to have a bunch of lines that look like this in order to make, you know, in order to load all these for. In fact, I'll just do it right now. I'll just do the orange guy. Yeah, let's do that. I'll do the orange guy, and then maybe next time I'll do the blue guy, or maybe in a follow-up or something. So, all right, I'm going to leave orange guy image, and instead I'm going to say p image m orange guy, and then there's up. Up, down, left, and right. So, again, this is not the way a professional programmer would do this. I don't know if this thing has arrays, but usually you want to have an array, and then you would say, you know, this being an array, you know, a block, a list, basically, in conventional terms. And so then you can refer to them by number. So you would be able to say m orange sprites or frames in that animation. It's not an animation. Orange sprites, orange guys maybe, and then you would say orange guys 1, or 0 is the first, you know, is the first one, and then 1 is the second one, and 2, and so on. And yeah, that's like kind of the better way to do it. But since I don't want to talk about arrays and loops and all that stuff just yet, I'm going to stick with just copying the code, which, like I said, it's bad practice, and you definitely shouldn't do it this way. But for pedagogical purposes, that's what we're doing. So I'm going to change this now. I'm going to move this back over here. This is the D guy, orange guy image. So I'm going to call this orange guy D. I believe that's what I call him. Orange guy D. Yeah. So, and I'm going to again do what I would be doing in a loop normally. 1, 2, 3, 4, and move down, up, right, and left. And kind of wish it would give me a little more room to work with here. But that's okay, it doesn't. So we just have to be extra careful and making sure that we're lined up with the right thing. So U, R, and L. Okay, so now if you remember from the previous video here, we loaded the image and it doesn't display it on the screen until you use this image function or method. So we have these in memory, and which one do we show? Well, we're telling it to show the orange guy image and the blue guy image. And the blue guy image is this, but we haven't. I renamed the code here, so I haven't specified what orange guy image is. This isn't assigned to anything anymore. So if I hit play right now, well, I stop this one and then play it, you'll see that I expected the orange guy not to be there, but I guess neither of them are there. So it has failed silently. All right, and I'm going to stop right here, and I'm going to copy this, and I'm going to show you. Like, I know what I've done wrong here, and I did it intentionally. But say I didn't know what I was doing, I did get an unexpected result. So I've just copied and pasted this into the actual processing, and I will show you the real reason why I have it. It's not just pretty colors, it is this. When you hit run, that's the same thing. We have it. Oh, come back here. Windows 7. Don't shake your images in Windows 7. Okay, so yeah, so we have the same problem, which is an empty screen. And then, so why do we have it? Well, we have a null pointer exception. This is Java telling us what the error is. Now, you can debug, and like it says, use Firebug to help debug your code. Firebug is a browser extension for Firefox, and you can get it for Chrome too. I'm using Chrome right here. And it makes it really nice to step in and step through your code. But it steps through the JavaScript code on a page. So if you're writing in JavaScript, I highly recommend getting Firebug for whatever browser you use. But this is processing, and the processing language is being compiled into JavaScript. So we write our nice clean code, and it's going to turn it into a bunch of kind of computer generated JavaScript. So I don't like debugging in this thing. I really like it for sharing with my friends and putting stuff up on the web, but I much prefer to use the actual processing thing, because when you run it and you get an error, you get an actual error message with a stack trace. Now, I don't know why I can't oh, there we go. I don't know why I wasn't resizing a second ago. That's odd behavior. There we go. Okay, so anyway, this is the error that is causing, well, the blank screen is indicative of the fact that there's an error. And since we don't know, like, as I said, I had expected to see one of the guys there, because I know I'm not assigning this M orange guy image anymore. I changed all the names to down, up, left, right. And I've declared it, but I haven't assigned it. And so, I know the fix is to do, whoops, not to do that. I know the fix is to say M orange guy image equals M orange guy U, and that's why we're having this problem. But how would I have known that if I just stumbled upon an error and been confused, and I would have looked in this and I would have hit the run button, and I would have gotten this error message here. And so what you're looking at is called a stack trace. basically, this is telling you at the very bottom, it's saying that the outermost shell or layer of the program function, I guess, it's a Java lang thread, which is a class of Java, calling this method, and it's running. Or I'm sorry, that's not a parameter. That's actually the source code in the Java SDK. So that line right there is where we're at in the Java system. And then that thread is calling this processing core p applet, which is the actual running thing. And we don't know where the source code is. Probably didn't have the source or whatever. And then that run is calling handle draw. So probably it's in a loop and it's handling the draw event. And that draw is calling lesson1 draw. And I have called this file lesson1. So this is actually the error. So on line 68, and if you look right, I don't know if you can see, if it's in my window. Let me scroll this down. If you look down here, you see this number right here changes as you press up and down. Well, that, you got it kidding me. Oh, of course. So yeah. So again, as I said, with the JavaScript, you're in the browser here, it's being compiled to JavaScript. Well, here it's being compiled to a Java class called lesson1 Java. This is lesson1.pde for processing whatever PDE stands for, and this is converted by processing into lesson1.java. So in the generated code on line 68, that's where you have the that's where the error is. So this actually isn't as useful as I might have thought, but it does at least tell you that it's a null pointer exception, and that means, what is a null pointer exception? That means that null means nothing. Null means it's when in Java, and therefore in processing, if you say int I, that I has, and you say like this, that I has the value of 5. If you don't give it the 5, it has a value of 0. Well, you can say, p image equals, p image Fred equals load image, path to Fred.png or whatever, and that is assigning a value to that Fred image object. Okay, the p image object, I guess. And since all of these don't have, they don't have this assignment thing, they need a default value. So we have an image, but we haven't given it a value, and so the name for that not having a value is null. Okay, so here we have the variable name is a they call it pointer in memory. So pointer just means it's telling the system where in memory to look for that image, and so we have a pointer that's pointing at nothing, and that's what null is. And so this null pointer exception means that basically that we have a pointer or a variable name that is pointing at nothing, which means we haven't assigned it yet, and that's telling us that we need to assign it here. So if we stop, I guess you stop it up here. Now that I've added this line of code in here, we can run it, and we get the guys back. And you see he's now looking at he's the guy going upwards, which I guess in a 2D world that's not necessarily the best thing. All right, so he's going upwards. I'm going to move him. Let's make him the right guy because we haven't seen that yet. So I'm going to make him face right by changing that R. And now you're starting to see why I did that. There you go. And again, this is being updated on every tick. So let's switch them back and forth. I want to show you kind of the principle of animation here. We're supposed to be doing keyboard stuff, but this is kind of tied into the keyboard stuff. I guess the thing I'm building towards here is I want to change the image based on what key you press, so that when you move left, he's facing left, and when you move right, he's facing right. It's kind of not. It's kind of a bit more than what we were assigned, but that's just I think it looks better to do that. I think people would want to do that. So I'm going to just show you real quick how to do something. Let's go ahead and make a variable called I, assign it to 0, and then I'm going to show you a if statement here, because we're going to have to use an if statement in the keyboard stuff anyway. I think, I'm pretty sure. Maybe not. Might be a switch statement, but we'll see. So we're going to say if I, and I'm going to go even and odd. And I'm going to say int x equals 50. All right. If I and to go even and odd, you want the remainder. You basically look at the remainder when you divide by 2, and this little symbol right here gives you the remainder. It's called modulus or modulo or just mod. So we want to say if I mod 2 is equal to 0, which would be an even number, divides evenly by 2. And again, we put the little braces, so we're saying if that happens, then what we want to do lives inside these, in between these little braces. And I'm going to say m orange guy image equals m orange guy left. This is, and then if it's not, which the word else indicates, then I'm going to say m orange guy image equals right. And I think that's ugly, so well, I'm going to show you what it does, and then I'll show you how to clean it up better. So we delete that, so we only assign it once. And then I put this X here because, well, I'll show you. This is going to make him kind of move back and forth really, really quickly. It didn't. Oh, because we didn't count. I++. You ever heard of C++? C++ means take the number C and add 1 to it. I++ means add 1 to it. Add 1 to I. There we go. So there it is, shaking back and forth really quick. And that's done. So we can change the rate at which it does that by changing our frame rate to something ridiculously low. And that reveals the fact that they're not clearing the screen, which we will need to know when we're moving them around. So, how do we clear the screen? That was actually in here. I think this does it. I think if you do this, it does it. Let's see. Yeah, okay. Yeah, I wonder if you can set other numbers in there. Let's try that. Let's see if it takes RGB or whatever. It does. Okay, so if you are a graphic designer and you do HTML stuff, you might know that you might be familiar with hexadecimal codes. And in Java-like languages, you type 0x to make hexadecimal. So 20 or let's see, yeah, whatever. 25 is by default a decimal number, base 10. But if you put 0x25, then that's whatever. That's 16 times 2 plus 5. So I don't do math in my head anymore. So anyway, so the point is you can use those same RGB codes. So if you're familiar with HTML, you can make red by FF here and then OX. Let's make some green in there, which would make it 99, and then OXCC, which is a little bit of, what is this? RGB. This would be kind of a purpley gray color, I think. Yeah, purple or pink. And that's not what I wanted. I wanted CC99. Anyway, you can see how easy it is to kind of get a rapid feedback. That's not what I wanted either, but it doesn't matter. We can change the color to whatever we want. And in fact, actually, we wanted to put a background in here. P image m background. And now this will bring up another question, which is the display order. Background. .png. Oops, I copied again. And back. I should call it image by convention. And I'm going to put these on here. And this is our low tech spreadsheet. They're all member variables, but these are the ones we draw. And low tech spreadsheet. Since we're not using arrays yet. Okay. Anyway, so I'm just going to load that image and we'll draw it. Instead of drawing the background, let's draw the so we put this background statement in there to clear it, but we can also clear it by drawing a gigantic background image on top of everything. So image and background image 0, 0. Drawing it at the upper left hand corner. Since it's 300 pixels tall, we'll get the left hand side of that. If it works. Yep, there we go. So there's the left hand side of my little hockey rink or whatever that thing might be. And there's our guy moving back and forth. This is really slow. So we could move it. We could change this to if we want to have other animations running around that move faster than that, then we should probably change that 30 back. So I was actually gonna. I'll just go ahead and do it. I was gonna, because I expected them to be moving back and forth really quick. I was going to put him at X. That's okay, because we're going to use X in a minute here anyway. So let's move him at X and Y. And instead of 50, we're going to list this. So made up Y at int Y equals, int means integer again. And int Y equals, we can do the same kind of thing. We center it. Kcanvas, so to center something, you take the height, divide by 2, the height of the canvas divided by 2. That's the center of the canvas. And then, since we're talking about the left-hand coordinate of this guy, we have to, I think we subtract. We might see that in a second. So we just change the height. So centering vertically and horizontally, pretty much the same. So this is going to be at X and Y. The orange guy should be centered on in the middle of the screen here. And it's not. Because a null pointer exception. So this is saying that on the very first frame, orange guy image hasn't been assigned yet. Well, that's because we put this above that, which isn't good. So I'm going to, let's move it down here. Okey-doke. Stop. Play. That should fix it. There we go. And then, again, this is totally just for fun. I'm going to put x minus equals, yes. Well, if we're going to change that on every frame, then where'd it go? Oh, down here. Oh, okay, we can't do that. So we have an order here that we can't break. So what I want to do is I want to, what I want to do is have him move back and forth left and right. Now I'm showing how to actually move the guy. And the way to move the image is simply to change the x and y values that we're passing into the image function. So I'm extracting them into these variables. Okay. But the problem is I want to I'm having an order of operations or ordering issue here. So I'm just going to fix it and hopefully this will make sense. Int x equals 0. So I'm moving it out of this draw image because right here, x and y are being created every time draw happens, and they don't live on after this after the program reaches that thing, that ending brace. Once we exit this draw routine, because we've declared them in the middle of draw, they just go away. And so if we move them out here, and y. So I'm going to call this m red guy x. Again, it's now a member variable. This should be called mi. M red guy y equals 0. And let's copy that name down here. So again, this centers it. And actually, another way we can fix that null pointer exception, would just be to move this to the, or copy it, and so it also happens in setup. So when we leave setup, we don't have any null pointers. In fact, that's probably a good policy to have for any code that you write. Is once you get unless you're going to use a null value later in your code or whatever, you should initialize everything up front. So initialize our current frame images, and well, we don't have that for blue yet, so that's right. I'm leaving it for you as a exercise. Okay, so there we go. So this is now assigned in startup, and so we have, by default, he's looking left, and so now we could put this back up here. And okay, and I know I haven't run it in a bit, but I'm just going to say one more thing here. Every time you use this int word, and the fact that you've declared a type and then a variable name is redefining it. So as I said, this and this are different because of this int keyword. So if I want to actually refer to this one, the class scope mredGuy, then I need to get rid of this. And this should be y. Component.x is not visible. Well, that's because we are not calling it x. And why aren't we calling it x? Because we are going to move the blue guy too, or you're going to move the blue guy. And so it doesn't make sense to just call it x. You want to be as specific as possible. All right. There we go. He's moving back and forth again. And then what I wanted to do here was actually say if I first. So if I had, I guess I haven't said this explicitly yet, but within these blocks, this is called a block. The brace, the opening brace, and the end brace define a block, and within a block, the functions or lines or whatever get executed from the top down. So there's a sequential order to them, and so at the start of each frame, we're going to draw the background. In fact, let's even write this out in comments. Draw. That's what comments are for. Draw the background. Position the red guy, orange guy, and just for fun, move him back and forth. And I'm going to call I want to m frame count is what I really is. So whoop. There you go. So and in fact, oh, okay. So if it's an even number, m red guy x minus equals a quarter of the canvas. I grabbed height instead of width. Width divided by 4. Quarter of the canvas. That's literally a quarter of the canvas. And here we're going to move it to the right. So I said plus plus adds 1. Plus equals just says, you know, this right here, this minus equals and the plus equals is equivalent to equals the same thing minus that. So this and, you know, this right here is just a shorthand for this, and it's much clearer to read because you don't have to make sure the two variables are in sync or whatever. If you change it, you're less typos, that kind of thing. So there he is. He's moving back and forth. All right, so there we have him moving, but we're not moving by input. So that's what we need to do next, is actually get an input. And I have been talking for a long time, so I'm going to break this now, and we'll move on to the next little lesson or step.